Hey guys, welcome back to another video. Today we're gonna do something a little different. At first, I wanted to do like a data stream question because I had no idea what data stream even meant. But then I realized it was a lot more complex. Not even complex, I just don't really understand the basis of the question. So for now, I mainly just took a quick look at it and didn't really understand what it was asking for, and then decided to move on to something a little different. So today we're going to be working on a game theory question, which is something I'm not really used to, but it seems like a really interesting topic. Don't really know what like the definition of game theory is, but today's question was really thought provoking. I don't know, it like took a lot of thought, but I think the solution was 4 lines of code. Like I'm so serious, and like I think like the some of the other people's solutions was 1 line of code. So it wasn't like the hardest question, but conceptually game theory is not something I've really done before. So for me, it was kind of a struggle. You can see me trying to look here, trying to understand the data stream. I'm like, what is going on? So we're mainly just going to be skipping over that. But yeah, thank you guys for watching, and I hope you enjoy the rest of the video. And I hope you have a great day. It's first day of classes tomorrow, so I'm excited for that. I'll see when and what time I get to squeeze in a question. I'm kind of worried that I'll only be able to fit it in like from my time to class and just do them on my laptop, and I can't record the videos on my laptop. So I don't know. Maybe I can record them on my laptop. I'm not sure yet. I got to figure that out. But anyway, yes, thank you guys, and I hope you enjoy.
You are playing the following NIM game with your friend. Initially, there's a heap of stones on the table. You and your friends will take alternate turns. You go first. On each turn, the person whose turn it is will remove 1 to 2 stones from the heap. The one who removes the last stone is the winner.
Yeah, as you can tell, I was definitely not the greatest popcorn reader in throughout school. So basically, what this question is asking is, you've got these stones, and if you optimally take as many stones, if you take, you can take up to 3 stones. If you optimally take the amount of stones, then if you can win the game doing that, then you want to return true. Otherwise, you want to return false. So I'll kind of let the video roll to see like where my thinking's at. I pretty much nail it right on the head right away, except I miss like one little nuance that I'm just like super close to, and I jump around it for like 10 minutes, and once I get that, I basically solve the question.
Alright, well, that's kind of easy. All we have to say if n is less than or equal to 3, returns true. So basically, this should be a pretty easy question. Oh my gosh, they are so loud. So we have the 3 stones. 1, 2, 3. If we have 3, if we have 3, we win. If we have 4, we lose.
This key element of losing on 4 is something I completely skipped over way too fast. Basically, it's the foundation of the entire question. Every time it's a multiple of 4 stones, you lose, and I walk around circles for 15 minutes trying to understand at what interval you always lose at. But I eventually get there, so don't lose faith in me, guys. Also, yes, the people near me are moving into college today, and they are loud.
4, we lose. Because if we take 1, we lose. If we take 2, we lose. If we take 3, we lose. 5, we win. Because if we take 1, that would leave 4. 6, we can.
I hope you guys are also starting to see the pattern. Basically, when here in a second it should start. When I divide by mod 3, which gives you a remainder, which the 3 is actually not the number you're interested in, because like I just said, it's actually multiples of 4. Whenever there's a multiple of 4, you lose. So here you see I do mod 3, which works like 50% of the time, because mod 3, when it equals 1, has a high chance of ending at a multiple of 4, but not guaranteed, which is kind of where it fails along the line of the algorithm. So instead of doing n mod 3 equals 1, you want to write n mod 4 equals 0, which means that the number given is a multiple of 4. Therefore, it's going to mean that if you play first, you're bound to lose.
7. Okay? We win. We win. We lose. We win. 1, 2, 3, 4, 5, 6. We take 1. We win. 1, 2, 6, 7. 7. We take 3. We win. 2, 3, 4, 5, 6, 7, 8. We lose.
This is 100% the moment I should have realized that the multiples of 4, as you can see, 4 and 8, we lose, is when you always lose. But for some reason, that just didn't really click here in the moment. And I just go on looking at like the differences or the count here. I wrote 8 and 4 next to it. How it isn't like speaking out to me is crazy. So I'm like doing floor division and I'm gonna like add and multiply to see if like I can find some sort of pattern while it's literally screaming at me in my face, which I think is kind of funny. Which I kind of like the nature of like the game theory question like that. So I think it's cool.
Okay. Multiples of 3. I'm trying to think. Wait. Where do we lose? We lose here, which is 4. And we lose here, which is 4. I've been chasing the wrong number. It's not this. It's every multiple of 4 you lose. So you can keep that. If n... Oh, that's not what I wanted to do return. If this returns a 0, you will lose. There's probably nothing else, right? Otherwise, it's true. Oh, and not 4, or not 5. I meant 4. Right? And then if n is anything less than 3, we win. Sweet. That wasn't too bad. Took me a little bit. Why is this? I guess variation. That's what I wrote. How does that even? Oh, actually, okay. Well, he didn't need. Okay. All right. Well, that was today's question. Game theory is interesting. Because I've never done it. So, yeah. Jeez, I have to edit this today. Oh gosh. Oof. It was fun. I liked it. All right. Well, thank you guys for watching, and if you enjoyed, please leave a like. And yeah, I think this was a very interesting question for me because it just it's so simple, but like I don't know, just I don't know. Those other ones, those data stream ones though, I'm gonna have to look into actually solving those because I don't actually really know what they're asking for or like what again like what they're even asking for, which makes it like really it makes like I can't even understand the question because I don't even understand what I need to be returning, and I don't want to sit here and waste your guys' time by me recording myself figuring it out. So I will try and figure that out. This is definitely a really easy question. But yeah, it's good. Thank you again. Thank you guys for watching.